calculating things, any angle that we use has to be in radian mode, so we can never use degrees in any of our formulas. So velocity is just like a speed, okay? When we're talking about linear and angular, we are looking at two different things. Most of the speeds you're used to are linear speeds, like miles per hour, feet per second, those kinds of things. Angular speed is how fast the angle is moving, not the actual distance that you are traveling. So the first definition we have, if you have a point P on a circle of radius r, so we have a circle, okay, we'll put a point out here, and it moves a distance s, so s is how far you go on the outside, because that's your arc length. And if I want to know how fast that point is moving on the outside of the circle, that is linear velocity, or v. And you find velocity or speed just by doing distance divided by time. So it's linear, so we take our linear distance and divide it by the amount of time. The angular distance, or angular velocity, is talking about the same scenario. We have a circle, and we have a point that is a horrible circle, point on the outside, but instead of talking about how far the point moves on the outside, I'm talking about the angle that's created. So as my point moves from here to here, I'm looking at how much has this angle changed. That is my angular velocity. So velocity is distance divided by time. This time we're looking at the angle, so that would be theta divided by t. Omega here representing the angular velocity. So theta and omega both have to be radians for this to work. We can also talk about how these two are related to each other. So we've seen this S equals R theta formula before. Okay, we know that, okay, let's take our V formula. If we said V equals S over T, that's the formula I gave you. Then we could use this and replace my S with R theta. And what does theta over t represent? The omega. So the third and final formula that we're using is V equals R omega. The next slide just has a summary of those. Your book gives a formula, V equals R theta over T, that just results in the middle. I'm not going to give you that one because it's kind of unnecessary. So on your formula sheet, I would have these three listed. Right, so now we're just going to practice using them. It would be extremely helpful to me now if you would make your list of variables, what everything represents, and write out what formula you're using, because sometimes there might be different approaches. So I need to know how you are getting your answers. Okay, so suppose that P is on a circle with radius 15 inches. I'm just going to write down R equals 15. And ray OP is rotating with an angular speed. What's my variable for angular speed or velocity? The omega, the W looking thing, is pi over 12 radians per second. Part A. Find the angle generated by P in 10 seconds. So this 10 seconds is my time. If I want the angle, what am I looking for? Theta. So, what formula would we use?
You would use the omega equals theta over 2 divided by pi over 12 over 10.
So multiply over the 10. So we have 10 pi over 12 or 5 pi over 6. Since my angular speed was radians per second, this is radians as well. I have some people who like to write out for me or write out their units as they go through, and I can show you that as well if that helps. We know if we're looking at an angle, we don't have to put a unit if we're dealing with radians. So my answer is just 5 pi over 6. Part B, find the distance traveled by P along the circle in 10 seconds. Distance traveled, what variable is that?
That's the
That would be a speed. I want the distance on the outside of the circle. S, arc length. So we're looking for S. So our list of options for formulas that we have so far. We know S equals R theta is still from before. We have V equals S over T, omega equals theta over T, and V equals R omega. So when I pick my formula, I kind of look at this. I'm talking about S, so that means I can either use S equals R theta or V equals S over T. Do we have R and theta? R was given in the problem, and didn't we find theta in part A? So that would probably be the easiest option because we already have both of those. So S equals R theta is my formula. My radius is 15. Theta is 5 pi over 6. So I'm not going to multiply out the pi, so 15 times 5 divided by 6, so we get 25 pi over 6. S, that's a distance on the outside. We know the radius was measured in inches. The arc length would have the same unit, so it's 25 pi over 6 inches. C, find the linear speed. So linear speed is what variable? So I can do V equals S over T. Do I have S? Yes. Do I have a T? Yes. The other option is V equals R omega. Do we have R? Yeah. Do we have omega? Yeah. So we can use either one. That's why I really like it if you write down what you're using. Which one do you want to do? Divide or multiply? Okay, so V equals R omega. V is equal to R, which is 15, omega, which was pi over 12. So that gives me 15 divided by 12, or 5 pi over 4. Your units on this, it's a speed, so it'll be something per something. V is linear, so your linear measure is what we use for the radius and the arc length, so that's inches per. The time in this was measured in seconds. If you struggle with units, sometimes people like to write it in the problem. R was in inches. This was pi radians per second. Radians are like the extra unit. If you don't have a unit, it's radians. If you have too many things, the radians disappear. So that's where we get the inches per second from as well. Any questions there? Okay. Let's look at this one. So a belt runs a pulley of radius 5 inches. The radius is 5 inches at 120 revolutions per minute. Okay, so we have to kind of decide what this means. When I see something per something, that tells me it's one of my rates. It's either linear or angular. If you're talking about a revolution, that means all the way around the circle. So is that linear or angular? Angular. Okay, so it's kind of like our omega, except there's a problem, because I told you that anytime you're using it, it has to be in radians, correct? Mm-hmm. So that's what part A says. Find the angular speed in radians per second. So we have to convert. We currently have 120 revolutions per minute. So if I want to get 2 radians, so I want my revolutions to disappear, 1 revolution is all the way around the circle. How many radians is that? 2 pi. So now we're in radians. All right, minutes into seconds. So I need my minutes to disappear. I want seconds. What do we know?
60 seconds.
So then we multiply. I'm not going to multiply out the pi, so 120 times 2 divided by 60 gives us 4 pi radians per second. Find the linear speed of the belt in inches per second. So linear speed is what variable? V. So we're looking for V. So what are my options? The only thing we know, we had R and we found omega, so we could do V equals R omega. We had 2 different versions of omega. To use it in the formula, it has to be radians. So we have to use the 4 pi that we found. So again, you may not like to write out units within your problem, and that's fine. If you're one of those people that do, you're welcome to. This is like 5 inches, 4 pi radians per second. When you multiply, the radians disappear. So we get 20 pi inches per second. Questions there? Let's look at this one. A satellite traveling in a circular orbit 1,600 kilometers above the surface of the Earth takes 2 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers. Approximate the linear speed of the satellite in kilometers per hour. All right. So we know from here to the edge of the Earth is 6,400, and we're another 1,600 beyond that. So what can I find? Yeah, add those together. So our radius is 8,000 kilometers. What am I looking for? V. Okay, we know we have 2 hours, so our time is 2 hours, to make an orbit. What's an orbit mean?
360.
And we want to be in radians, so all the way around would be 2 pi radians. So we need V. So the options for V are V equals S over T. I don't have S. Or V equals R omega, and I don't have omega. So either way, I'm either going to have to find S or omega to begin with. Let's say I wanted to find S. How do we find S?
Check 8,000 times 2 pi.
S equals R theta. So that would be 8,000 times 2 pi. So S is 16,000 pi kilometers. Right, so then we have S, so we could do V equals S over T. So 16,000 pi kilometers divided by 2 hours, and we get 8,000 pi kilometers per hour. B. Approximate the distance the satellite travels in 4.5 hours. So the satellite is traveling out here. The distance it's traveling, what variable is that? S. So we're looking for S. Now we found an S before, but that was based off the 2 pi, which was a time of 2 hours. Okay, so it's not the same S because it's traveling longer here. We know now our time is 4.5 hours. Would my linear speed be the same as we found in part A? Yeah, we're not changing speed. So we could do V equals S over T. So V is 8,000 pi equals S over 4.5. Multiply over the 4.5. So we get
36,000.
maybe 6,000. S is just the distance, so it's kind of like your rates. It's just a symbol. So all of the rates are something per something. The others are just a symbol. All right. Is this one okay? Let's do just a couple more and then give you guys some time to try some on your own. Find the angular speed. Angular speed is what? What variable?
Omega.
of the minute hand of a clock. Alright, that's not a lot of information. We know that omega is theta over t. So we need a theta and we need a t. We can actually pick any theta and t that correspond to each other because we know we're talking about a clock. So let's say I just did 2 pi. Okay? That means all the way around the circle. So if the minute hand, if it travels all the way around the circle, how much time has passed?
60 minutes or more.
Right. You can use either. You just have to make sure you're labeling your final answer. Because I did not tell you if it had to be radians per minute or radians per hour. So if we divide this, we get 2 pi divided by 60, so that would be pi over 30, and that was radians per minute. If you use the 1 hour, what would you get?
Just
Yeah, 2 pi radians per hour. Could you do seconds if you really wanted to?
yeah.
Yeah, you just have to have those labels on your answer. That's why labels are so important. Any questions there? Right. Last, find S. If R equals 9 yards, omega is 2 pi over 5 radians per second, and t equals 12 seconds. Also, always make sure that your units match. So if your rate is in seconds, make sure your time is in seconds. You know, if I said the time was 1 minute, we want to convert it into 60 seconds. So make sure those are the same. So options for S. We can do S equals R theta, but I don't have theta. Or we can do V equals S over T, but we don't have V. So either way, we have to find something, right? Let's say I want to do S equals R theta. So I have my R. We have to figure out what theta is. What formula could you use to find your theta? So omega is 2 pi over 5 radians per second equals theta over 12 seconds. Pi over 12. We get theta to be 24 pi over 5. So then if you multiply, what would my units be? It's not a speed though, it's S, which is your arc length. Or if we think about this, this was 9 yards and theta was radians, right? When you multiply, if you have radians times anything else, the radians just disappear. It's just yards, it's not per anything, just plain yards. Alright. So, I want to give you guys some time to work. And these are every other odd, so it's like 3, 7, 11, 15, so forth. Some of them are pretty basic, just plugging things into the formulas. Some of them, then we get into more of the word problems like we were doing. This is going to be due Friday. So we will have some class time tomorrow as well, but I'm going to give you, we're going to do a little more reviews. So it's not just a full work day tomorrow, we are going to be doing some other stuff as well, but this won't be collected